Hello everyone, welcome to BrainPhront. My name is Subhobroto and today I'll be guiding you through the parallelogram law of vector addition. So in the last lecture we discussed about triangle law, which involved adding two vectors, say vector A and we have another vector B. So in triangle law, what we did that we used to pick and place any one of the vectors such that the tail of the picked vector is placed right at the point where the head of the vector which we have not picked is placed. And now in order to get the resultant vector, we join the tail of the vector which we didn't move to the head of the vector which we had picked and placed. So the resultant would turn out to be this yellow vector. This vector would be called A vector plus B vector. This was one arrangement, as it involves the use of a triangle. It forms the shape of a triangle and hence it is known as the triangle law of vector addition. Now we'll discuss about parallelogram law of vector addition. So parallelogram law of vector addition. Basically, parallelogram law does not have something much more different than triangle law. It's just another arrangement of the way we find out the resultant graphically. So, say there are two vectors. Say these two blue vectors are placed, and I have another vector. Say B vector. This is A vector, and this is B vector. Now, as per parallelogram law, if I want to add these two vectors and get a geometrical representation of the resultant vector, what I need to do is I need to pick and place any of the vectors and match both their tails together. So I've picked and placed both the vectors and now their tails are matching. They are at the same point. Now the resultant vector, in order to get the resultant vector, we need to form a parallelogram law. We need to form a parallelogram using these two vectors. But now we have these two vectors. In order to form a parallelogram, we need four sides. We have just got two sides. So we would basically replicate these two. We would replicate these two. Say this is B vector. We would replicate these two. And say this is A vector. Now see, this kind of forms a parallelogram, right? Now in order to get the resultant vector, we'll join the diagonals formed by matching these two tails. The diagonal which involves the point which is formed by matching these two tails, and the point which is formed on the matching of these two heads. So basically the resultant vector would turn out to be this green vector. So this is A vector plus B vector. Now you happen to see that we have in a way implemented triangle law. If you look at this section, the green vector and these two blue vectors are actually very similar to this diagram. In fact, even we can say that the above diagram is also a resemblance of the triangle law. So this is just another way to represent graphically. Parallelogram does not change any specific formula or any method which we implement to get the resultant vectors. It is just another way we can represent vector addition graphically. So the formula of the magnitude would still remain same, because you see indirectly we have still applied triangle law, right? So say this angle was theta. So the magnitude of the addition of these two vectors would turn out to be a square plus b square plus 2ab cos theta. Note that when I am writing a without an arrow on top, it represents the magnitude of a vector, and b similarly represents the magnitude of b vector. So this is the way we can add two vectors using the parallelogram law. Now what about the direction? Well, in the previous class we had derived the direction. So what we simply did was that we instead broke b vector, or we represented b vector, we split it into the addition of these two vectors, right? This was b cos theta. The magnitude of this vector was b cos theta, and the magnitude of this vector was b sin theta. Now we applied the concept of tan phi. So tan phi turned out to be square root of, tan phi turned out to be perpendicular by base. So perpendicular by base would turn out to be b sin theta by a plus b cos theta. So till now we have learned how to add vectors. If we can add vectors if we are given the magnitude of both the vectors and we are given the angle made by the two vectors, and we can also find out the magnitude of the resultant vector, and also we can find out the angle made by the resultant vector with any of the two vectors. So we will now try out some problems so that we can practice what we have learned as of yet. So say that say that we have one vector. Say we are adding two forces, right? So say we have two forces acting on a particle. Now one force is acting in the horizontal direction, and it is 5 newtons. Its magnitude is 5 newtons. And now I have another force which is acting at an angle of 60 degrees. It is acting at an angle of 60 degrees. Its magnitude is also 5 newton, right? And here is the particle. This is the particle on which it is acting. By a particle we refer something which has it's the size of a point but has mass, right? So in any case, the forces, the point of application of all the forces on the particle would end up being the same. So basically we would not discuss the point of application of force. Say if there is a rod and if I apply two forces in this direction, this would not only provide acceleration to the system, but this would also end up rotating the system, right? There is a possibility that the system might start rotating. See, this is a similar diagram, like as if we are opening a water tap. So this diagram resembles quite something like that, and we always end up opening, or what I want to convey, that we end up rotating the system. So for a particle system, the particle is so small that all the points, that there is just one point of application. So no matter how many forces I apply, it would not produce any rotational effect as of now, right? So similarly, if we need to add these two vectors and the angle between them is 60 degree, so first let's find out the magnitude of the resultant vector. So by parallelogram law or triangle law, whichever law you wish, say I am applying parallelogram law, so I need to complete this diagram first of all and form a parallelogram. So I would form a parallelogram in this manner. And the other side would be now see, I have formed the parallelogram. So the resultant vector would be this blue vector, right? So this blue vector would be the resultant vector. Now what will be the magnitude of this blue vector? So what we can do is we can directly apply the formula, or we can apply trigonometry. We'll discuss both the ways. So say if I want to apply the formula, so the magnitude of say a vector plus b vector happens to be square root of a square plus b square plus 2ab cos theta. Now here let's take this as a vector and this as b vector, right? So for a vector the magnitude of a vector is 1, so a square the magnitude of a vector is 5, sorry, it's 5, so a square would turn out to be 25, b square would also turn out to be 25, and twice of ab, 5 into 5 is 25, cos theta, cos 60 degree. Now we know cos 60 degree is half, so this would be half. Now this 2 cancels this 2, and now we have 75, square root of 75 newtons, 75 newtons. So we can evaluate this, and the value would turn out to be 5 root 3 Newton. So the value of root 3 is approximately 1.732, right? The value of root 3 is approximately 1.732 multiplied by 5, so we would get 5 to the 10, 5 to the 15, 16, 1, 5 to the 4, 35, 36, 3. It's approximately 8.66 Newton, right? So it is approximately 8.66 Newton. Now what about the angle? What about the angle, right? So for the angle, what we can do is we can simply make the diagram which we used to make in triangle law. We would join this vector, we would join this vector, right? Now we get that similar triangle law diagram, and now I will split this as addition of these two vectors, right? Let me make it in another color. Right, so the magnitude of this vector is also 5 newtons, so this would rather be this magnitude would rather be 5 cos 60, and cos 60 is half, so this would be 5 by 2. Similarly, the magnitude of this vector would be 5 sin 60, which is 5 root 3 by 2. Now for this angle phi, for this angle phi, we can say tan phi turns out to be 5 root 3 by 2 whole divided by 5 plus 5 by 2. 5 plus 5 by 2 is 15 by 2. So now this 2 cancels out, and 5 by 15, so that's root 3 divided by 3, or 1 by root 3. Now we know that tan of 30 degrees is 1 by root 3. So obviously phi would be tan inverse 1 by root 3. Hence the value would turn out to be 30 degrees or pi by 6 radians. For now we can stick to degrees, and we would discuss much more about radians in kinematics, but if you are comfortable with radian, you can still go with radian, and if you are not comfortable, don't worry, we would discuss it later. You can still stick with degrees, it's fine, right? So now say I want to subtract these two vectors, right? I want to subtract these two vectors, so I want to say that subtract this vector, say this is a vector and this is b vector. I need to calculate a vector minus b vector. Okay, fine. So what I need to do, I need to simplify my vector diagram. So if a vector is this one and b vector is this one, right, this one. So if this is b vector, this is a vector, minus b vector would be in this direction, of the same magnitude as this one. Now if I add a minus b vector, it's indirectly subtracting both the vectors, so I can now remove this vector and I can perform this operation in order to get the subtraction of both the vectors. So the magnitude of this vector is still 5 newtons, right? And the magnitude of this vector is still 5 newtons. However, the angle has changed. The angle here is 60 degrees. So these two angles happen to be supplementary, which means the sum of theta plus 60 degree is 180 degree. So theta would turn out to be 120 degree. Okay, so I need to calculate the resultant vector. So what I can do is I can either form a parallelogram. Or I can continue with triangle law. So we can do any one of the following. So whichever suits your ease, you can perform that operation. Now the parallelogram has been formed. The resultant vector turns out to be this one. So the magnitude of this resultant vector mod of a vector minus b vector, right, would be square root of a square plus b square minus 2ab cos theta, right? So this would turn out to be 5 square 25 plus 25 b square, or let me just write the formula first. A square plus b square minus 2ab cos theta. Square root of a square is 25 plus b square is also 25 minus 2ab, so twice of 5 into 5, okay, so that's 25, and cosine theta. Now note that in vector addition we used to take this angle cos 60 degree as per the formula which I taught you in previous class. But say we are adding these two vectors, this is often a point where students can make mistakes. So let's say that we are adding these vectors, and we would end up getting the same answer if we used vector addition formula instead of vector subtraction. So let's first try out with subtraction what the answer turns out to be. So cos theta would be 60 degree, the angle which was initially made by a vector and b vector. Okay, so now we are subtracting, so the theta we won't change, we are directly applying the formula, so we would still take the old angle, right? So this would turn out to be square root of 25 plus 25 minus 25. So the answer would be square root of 25 or 5 newtons, right? Now say if I want to treat it as a vector addition, what I can do is I can add these two vectors very easily with an angle of 120 degree. Now say the addition of these two vectors, say, turns out to be r vector, okay, which is same as this blue vector. So the magnitude of this r vector would be a square plus b square plus 2ab cos theta, right? So this operation was performed as per this diagram. I had directly applied the vector subtraction formula using this diagram. Now if I want to flip this and make this minus b vector and then perform the addition, so it's still indirectly vector subtraction. So now I can easily perform this operation using the vector addition formula. So this would be 25 5 square plus 25 5 square plus 2ab, 2 into 25, or what I can say 5 into 5, which is 25. So that's it. And cos theta, in place of theta we would no longer take 60 degree, we would take 120 degrees, because now we are using this diagram. Previously we directly applied the formula and we were using this diagram. Now we are using a transformed diagram, this diagram. Any method you apply, you would still get the same answer. So cos theta, cosine of 120 degree, if you know a bit of trigonometry, you would realize that cosine of 120 degree is actually minus half. Cosine of 120 degree is minus half. You can learn this in any basic mathematics lecture which we would soon bring up on our BrainPhront channel, right? So we would also teach you about trigonometry and finding angles, cosine, sine and tangents and all other trigonometric ratios of angles above 90 degrees and 90 degrees and beyond. Okay, so cosine of 120 degrees is actually negative. Okay, so cosine of 120 degrees minus half. So you see we end up getting the same formula. So this would again turn out to be this 2 and 2 would cancel and we would still get root 25 or 5 newtons. Okay, so either we can directly apply the formula on both the vectors or we can transform the vector diagram. We can either apply the formula directly on both the vectors and treat it as a vector subtraction, or we can transform the diagram so that we can still treat it as a vector addition, but still the answer would turn out to be the same as the vector subtraction. So both the things we end up doing the same thing, but the methods are different actually. So whichever method you feel comfortable, like transforming the diagram, like flipping the vector back, or directly applying the formula, I personally feel that flipping the vector back, okay, it is much more clear and much more easier, and there are much less chances that you would end up making mistakes. Okay, so these are the basic problems which involve vector addition using both the laws. Okay, so uh, for now we are done with diagrammatic representations of vectors and graphical addition of vectors and finding out the magnitudes of resultants and finding out the angles made by the resultants. In the next lecture I would discuss about the components of a vector and basis vectors, right? Components, we would discuss components, and we would also discuss basis vectors, and we would obviously shift into a much better coordinate and direction system. Like it is really troublesome to deal with angles, especially when the angles don't turn out to be known ones. Say like if the angle is 40 degrees or angle is like 20 degrees, so obviously it is really difficult to perform vector addition without a calculator in such cases. So we would obviously change, and in fact telling about the direction of the resultant vectors with the help or with respect to another vector is also quite difficult. Like it in the 3D space, if we try to establish directions in with the help of angles, it's possible, but it's quite difficult and cumbersome. So what we would do, we would introduce a new directional system, and so that we could describe any vector accurately in the 3D space. Okay, so that's it for today. If you liked the video, hit like. If you disliked it, hit dislike. Write about certain suggestions in the comments below, and I will see you in the next one.